All right guys, now we're going to just go over the results of this test and just have a general look at the state of health of the battery of this car. So I've charged the car up to 100% over the past few weeks, just gone back to normal. I thought I'd give it a few weeks, let everything sort of settle in, and then we can have a look and see where the range prediction is, where the stats are at, and once everything's sort of, settled back to normal. So we did 2 weeks of supercharging only, and I didn't go higher than 80 or 90%. So we never really gave the car a balancing charge. It only ever saw high rates of charging, above 50 kilowatts anyway. So the charging rates never really got below that. So what I was trying to see by doing that was if we could create some sort of cell imbalance. And I was trying to think if we could, I know it was only 2 weeks, but I thought I'd see if there was any evidence of the supercharging only causing any problems. So really with a big lithium-ion battery in an EV, there's a few different ways that you can damage it. So you can overcharge it, you can over-discharge it, you can charge at high rates of power when the battery is cold, and the LFP battery can be damaged in that way. And high rates of discharge to a lesser extent can sort of wear a battery out. So it's only designed to do so many cycles, and by treating the battery poorly, you're going to reduce that amount of cycles, available cycles. So with the LFP battery, that amount of cycles should go well beyond your expectations, and should last a lot longer than a standard battery. But an LFP battery isn't immune to degradation. It will still degrade over time, just at a slower rate. So I thought I'd see after a year if there was any evidence of that I could tell, and see if there was, just look at some of the stats and go over things. So the other ways you could kill a battery are, having it at really high temps, and also using it while it's too cold. So you've got the temperatures. There's also, keeping the battery at a high state of charge. So we need to talk about that. Even though LFP isn't as damaged by keeping it at a high state of charge. So I want to just explain that again. I did that in my LFP battery video, but so normal non-LFP chemistry, nickel cobalt batteries, when you charge them to 100%, you are causing degradation with those batteries. So the battery, a nickel cobalt battery is at 100% under a lot of stress. So it charges to a higher voltage than an LFP battery. So an LFP battery, looking at mine now here, at 100% it's 375 volts. Now with 100% charge on a non-LFP battery, you're in excess of 400 volts. So it's under a lot more stress. Think of it as a, pressure. Voltage is pressure. It's building up inside the battery. So the higher the pressure you go, the more stress everything's under, the higher pressure there is. So with an LFP battery, you don't have as high a voltage per cell and as high overall voltage. So that's part of the reason why the LFP battery isn't as stressed. But it is also to do with the chemistry as well. It's less energy dense, but that keeping it at 100% state of charge with an LFP battery really is fine. It's not going to be caught, and Tesla even recommend it. Now I think if a car manufacturer is recommending you do something, then it can't be bad. So I think that's fine to do, and I do it all the time. And I think it's a must with an LFP. Once a week, we covered how the LFP battery determines the state of charge, and I think really across the board how an EV determines the state of charge left in the battery. So charging it to 100% with the LFP battery resets makes the battery management system do a reset and of the capacity of the battery and starts, and you'll get a more accurate state of charge. All of these ways I've been discussing to kill a battery, the majority of those Tesla manages with the software in the car. So you can't overcharge this battery, the car won't let you do that. You can't over discharge this battery. Actually, I'll correct myself, you can over discharge this battery. If you run it to 0% and then just walk away from the car and leave it, it will eventually over discharge and you will cause damage to the battery. But there are a lot of software and warning things in the way of you taking the battery down to that point. So it's managed. It's managed anyway. Temperature's managed very, very well by this car. So you don't need to worry about the battery getting too hot or too cold. Even when this battery is cold, the LFP battery, the car will limit what you can push in through that battery while it's cold. And that's why you get reduced regenerative braking and reduced charging speeds with the LFP battery when it's cold. And when we're talking cold, we're only talking, below 20 degrees, below 25 degrees actually is where a lot of these limitations happen. So you saw early in this video when I was charging, I was trying to charge with the battery at 32 degrees, and there was some limitation there, but it wasn't that bad. So I think really you're not going to find any of these things causing you too many dramas with the LFP battery as far as charging and things go. And that was part of me demonstrating some supercharging here because we wanted to, I think that's relevant to the LFP battery. So I wanted to show that charging at the start of this video, the charging session, to show that, look, I hadn't properly heated up the battery, but the software in this car manages that charging curve depending on the temperature of the battery. So you saw there that I came into it with a not too cold a battery, around 32 degrees. It's still not warm enough to get the maximum charging speed for this car, but you saw it still charged at a pretty decent rate compared to other electric vehicles. So that was the purpose of putting that into the video at the start. And I just wanted to explain the purpose of this as well. So I think really, a lot of those things are managed. So really, the only thing that Tesla can't manage is how often you supercharge and how you drive. Flooring it everywhere, making the battery discharge at really high rates is not going to be good for the battery. So Tesla can't control how you drive the car. They can't control how often you DC fast charge. And they're the things that they can't control. But while you are DC fast charging, they can change that charging curve. And I think over time, as the battery gets older, the charging curves will have to be changed as the batteries degrade. So what actually happens with the battery as it's degrading is the internal resistance in the battery just gets higher and higher and higher. So as the internal resistance in the battery gets higher, it's like closing a tap. So once it's harder for the electrons to flow, the peak output of the battery comes down. You get a lot more cell imbalance going on, which is the difference in the individual cell voltages down to that 3 volt level. And that was the other thing I was trying to see if I could, I was trying to create some cell imbalance. And with the LFP battery, because of the lower internal resistance of that chemistry, I believe that it's less prone to cell imbalance. And that's my my opinion through my experience and my research. I think overall the lower internal resistance of the LFP battery is part of its longevity as well. So as the LFP battery degrades, it's still going to have a lower internal resistance than a lot of other chemistries. So you're going to see less cell imbalance, and that lower internal resistance you saw gives you some regen braking at 100% state of charge as well. It gives you consistent acceleration and battery output, even down to lower states of charge. So there's benefits to that as well. So yeah, I think looking at that, I don't think there's a lot you can do to damage this battery, and I think the majority of people are going to sort of drive reasonably sensible with this car. They're not going to be supercharging all the time, so you should, see very, very little degradation with this LFP battery. So now that I've had the car for a year, I thought I would do this bit of a health checkup, and what we might do now is just go, I'm going to insert somewhere along in this video, I want to do an acceleration test on this car, and we want to have a look at the voltage sag. So when I floor it and put my foot down, take this car to its maximum acceleration, we're going to see where the peak kilowatts are, and we'll also see where the voltage drops down to. So under load, voltage, you get voltage sag. As you're drawing that voltage or that pressure out of the battery, the overall voltage drops down. And as the internal resistance of the battery increases with degradation, that sag will get worse and worse and worse until the battery just can't give any more out. And that's, I wouldn't mind, even if it's just to set a benchmark, so that in a year's time I can do that voltage sag measurement again and see where it's at. Gives me something to compare to. So I think that'll be a handy little thing to do, even if it doesn't really show us anything right now. I think it's a good benchmark test to do. So I might squeeze that in here at some point. We'll flick to that. We might even do it now before we go on to looking at some of the stats. Okay guys, we're just going to do the voltage sag test now. So what I've done here is I've heated up the battery. I just pretended, navigated to a supercharger, heated up the battery so the battery's all nice and warm, so we're not getting any limitation there. And what we're going to do is we'll do one run where we're looking at, we'll go to the battery screen here. Now this one here is giving us a lot of information. We're getting the total battery voltage up here. We're seeing currents. We're seeing a few things there. We'll do a run with this, and then we'll do a run with the other screen, the battery management screen, where you're seeing the individual cell voltages. So what we might do, we can see that at the bottom of this screen too, down here. You can see that there. So we might just keep an eye on that too with the run. So what we're going to do, I've got the car pointing up a hill so that we don't need to exceed the speed limit to get the car to do full output. But yeah, let's do the first run. I used to do this sort of test when I worked on electric forklifts. You'd load test and you'd check the voltage of each cell to look for consistency between all the cells. So that's what we're going to look here. So first run, 1, 2, 3, go. Okay, run number 2, where we're looking at all the individual cell voltages in the modules. So 3, 2, 1, go. Okay, for this third run, I've actually got the, you can see here, I've got the cell imbalance showing. We'll get rid of that. So 3, 2, 1, go. I've been inspired by Tesla Beyond, and we're going to put, I've tried taking a screen recording of my phone with ScanMyTesla, and we're going to superimpose that here on the video. So we might just put that up there now, and we can start looking at some of these stats in the battery. So I want to look at, this is the normal tab that I use when I'm driving. So you can see here we've got, I can look at the battery temperatures, I can look at the rear stator temperature here, I can look at the battery inlet temperature, we can see the max charge power. I'm at 100% state of charge, so that's why the max charge power is down at that point. Regen's pretty good, the battery's reasonably warm. So we can see that there, gives you outside temp. We're plugged in charging, so it's not giving me some sort of accurate, not giving me accurate measurements here on some of those. But okay, what we might do is go back over here to battery. So this is quite a good screen here. There's a lot of information. We can look at, I'm going to start at the bottom here. We're looking at the rated range. So down here we have 414 kilometers. If I go to my screen, I'm seeing 413. So I think it rounds up or rounds down sometimes on your screen. But we're seeing the rated range of 414 kilometers. Now, when I first got this car, 100% charge was 424 kilometers of range. Now, this is a little bit of a deceiving figure, because this range figure is based on a US EPA test cycle, and that's where this range is worked out from. So with some tweaks, your car will calculate this range based on that test, but how it calculates the range changes over time as you get software updates. So this is something that every now and again you'll read it, you'll get an update to the car, and you will say that you'll see that the range calculation has been adjusted to be more realistic. I think that figure still isn't very realistic. You need to go and use the energy app built into the car to get a realistic range figure. That is based on your driving history, your drive, your consumption for the last 25 or 50 kilometers. It's a bit more accurate based on your driving. The rated range of the car that comes up next to the battery symbol on the screen, that isn't based off your driving style. So that's based off of inbuilt calculation in the car. So that's where you need to be careful with those two range measurements. So I've seen that gradually decrease over time, but that doesn't mean that's degradation. So it's still a degradation in my range, but is it degradation of the battery? That's something that you can't be 100% sure of. And that's where these, for a Tesla, the range tests that you can do to check for degradation, your range is based off what Tesla allow you to use of the battery, the capacity of the battery that they allow you to use. It's based off that, and they can change that figure. Now, I want to move on to the next part of this to sort of segue into that. Now, one thing I want to look at first though is cell imbalance. You can see the cell imbalance here is at 4 millivolts. That's pretty good. Even with all the supercharging I did, it would just hover between 2, 4, 6, 10. I never really saw it worse than about 10, average of 10 millivolts. Now that's hardly any cell imbalance at all. And as I said, I think that's that's a bonus of the LFP battery. So as always with my videos, feel free to comment. If you've got ScanMyTesla hooked up to your non-LFP battery in your long range or your performance model, and you can give me some of the stats for that, that'd be great, because I don't know anyone with a long range with a non-LFP battery in a Tesla Model 3 to compare to, so I don't have that. I know some people with Model 3s with LFP batteries, same configuration as my car, and we'll talk about some of those stats in a sec. But yeah, you can see that cell imbalance just fluctuates around 6, 12. It really just, it's going to fluctuate a bit as the battery, the car has stopped charging now. It's really just powering the electronics. It's not really doing much. So those voltages there, there's little fluctuations in that all the time. And this app is pretty sensitive and it's picking up on that. But it's looking at the difference between the cell with the highest voltage, comparing it to the cell with the smallest voltage, and it's giving you the difference between those two. And you can see those voltages listed just above that, up here. Whoop, get rid of that. Sorry, I'm sort of new to this screen capture thing. But yeah, looking at that, we've got go up from cell temp. Now, what I want to talk to you about now is we want to look at some of these figures here. So there is, let's look at the full pack when new. So that is one thing that has not changed since I bought the car. It's been at 55.1 kilowatt hours since I got the car. Usable remaining is 50.5 kilowatt hours. That's how much I have to get to 0%. So from 100% down to 0%, I have 50.5 kilowatt hours of usable power, usable energy that I can use out of this car. So then we can see the state of charge is at 100%. Well, it's actually at 101%. It's just what this car does. We can see an energy buffer. Now this is the energy buffer after 0%. So you take this car to 0%, you have 2.4 kilowatt hours of energy remaining after that 0 point. So you can keep driving after 0%, but you're gonna really cause some damage in this battery if you start discharging it over 0%. And that was what I was talking about. That's something that Tesla can't stop you doing. You can take it down past 0% and keep driving until the car gets to, I think it's either 2.8 or 2.5 volts per cell. It will cut out to try and just ultimately protect the battery. It will shut the car down to stop you causing major damage to the battery. So that's the energy left after you get to 0%. So you can see there's a buffer there. It's a safety margin. So you should never really take it down to that point anywhere. The car gives you plenty of warnings before you get anywhere near 0%. So no excuse with all the superchargers there are all over the place. Then we're looking at there's nominal remaining. Now that is down to absolute cutout. So that is your usable remaining with the energy buffer added to it. And you get the 52.9. Nominal full pack. So this is basically an assessment of the capacity of the battery. And that's a figure that I have seen come down. But it has come down with the range prediction. So every time there has been a reduction in the range prediction with a software update, I've seen that nominal full pack come down. So if you look at that nominal full pack figure and minus your energy buffer, you will get the usable remaining left. So you're 100% to 0%. Now, what I don't know is there an energy buffer above 100% as well? Or, there's really a lot of information hidden. Tesla don't publish information about the specs of the cars, and other than the 0 to 100 performance, which is super important. But, I would love to have some of these figures, but if they tell you what capacity you should have and you should be getting, that's leaving them open legally for you to then have a figure to work against to work out your degradation. But they don't publish those figures. So you really don't have any figures to work with other than that range prediction. So really, in the manual, it's got a thing there that if the battery does degrade or find an issue with the battery, it will give you a warning message on your dash. So I spoke to the Tesla service guys. I questioned them on this range. They said my battery is healthy. There's nothing wrong with my battery. And I'm inclined to believe them. I really just wanted to inquire to see what they would say. I think that my battery health is great. I can see my power isn't being limited. I can see my cell imbalance is pretty good. It's really just, I think if you just look at purely these capacities here, you're going to think that your battery has degraded. So looking at these figures here, my battery is 4% degraded, but I know that I have seen that nominal full pack figure come down with the range prediction. So I'm not sure what's going on in the background there, but I'm not worried. I know this battery is still healthy looking at these stats. At least what we're doing here is we're documenting, we're setting some benchmark figures, and we can keep looking at that going on. So during this, I think I'm gonna put up some screenshots of my figures over time. So when I first got the car, a month after I got the car, Tesla, opened the energy buffer from 5 kilowatt hours to 2.4, 2.5 kilowatt hours. And at that point, my nominal full pack was 55.1. So what may have happened, in my opinion, is Tesla may have realized, okay, well, look, we've given these cars some extra energy, some extra battery capacity from the nickel cobalt battery version of this car. We've got a bit more of a top buffer there. Looking at the voltage of these cars, maybe they thought, well, let's bring the voltage down slightly, bring the capacity down slightly, just to take some capacity out of the top of the battery there, just to maybe increase the life. Maybe Tesla saw something in the data to say, okay, well, if we keep charging them to this point, or letting them charge up to this point, or giving this much energy to discharge, maybe, we're going to see some problems down the line. But that's just my guess. I'm not seeing any figures here that are causing me concern. It's something that I'll just monitor over time. I really think I'm pretty happy with this. As far as that range goes, going from 424 kilometers when I first bought the car, Tesla never guaranteed me of what a range I was going to get. They published a range figure of, I think it was 450 kilometers, with this car when I first bought it, which was an EPA test in America. But when I first bought the car, it was only saying 424 kilometers fully charged at 100%. But I didn't go to Tesla and go, hey, where are those 25 kilometers? You just understand that a lot of these tests, the WLTP test, they've got the European tests, you've got the American tests, it's a little bit confusing. I think really you got to be a bit casual about it, just be a bit relaxed about this, because those figures are based off tests in really controlled environments, and they're not realistic to, the everyday person's driving style. And I think just really be careful about how much weight you give those figures. So for me, if that 424 down to 414 now was causing me a problem, I didn't then have enough range to get somewhere, then I've probably bought the wrong car, because you shouldn't buy the car off 424 kilometers. I've got a 424 kilometer commute to work. I'm going to buy this car because it's got 424. Well, it's not going to be the right car if you have a 424 kilometer commute, because if you're commuting 424 kilometers, you're not going to be driving in the same fashion that is used for those tests. You get onto the freeway, you're going to be lucky to get 300 kilometers out of this car. So once you start owning an EV, you then learn where the realistic range figures are. And this 5-10 kilometers range difference at the top at 100% charged doesn't really make that much difference to you, because on a long trip, you're never using up that much capacity. So you only need enough range to get from one supercharger to the next, or possibly skip a supercharger and get to another one. You're never cutting it that close that it matters. And I think really this car could have 150 kilometers of range and it would still be a usable car in the city. So I don't know. I'm not giving that much weight at the moment. If next year it turns around and this car's only got 350 kilometers of range at 100%, then I'm going to start to worry. But I'm going to know there's something wrong with this car after 2 years. If the range has dropped by 100 kilometers, there's something wrong. So at the moment, we're talking, about 10 kilometers of range difference from when I first bought the car. But I do know Tesla have tweaked that range prediction. So the bulk of that range difference is because Tesla have tweaked the software. So I'm not too fussed. Looking at this battery, it's got a good state of health. It'd be interesting to see what figures you guys have. And I'm, from your cars, if you've watched my videos and you've hooked up ScanMyTesla to your car, I'd be really interested to see where your stats are. Whether your car's new, whether it's 6 months old. I've compared my stats to another car of a similar age to this, and they're exactly the same to the 0.1 of a kilowatt hour. That's where I think, you know, another car I looked at was 52.6 nominal full pack. I think Tesla have set that figure. I don't think it's a figure to assess the degradation of the battery from. So feel free to challenge me on that, because I'm not seeing, you know, the evidence that I've got in front of me are pointing to that figure being a set figure based on a calculation or a software tweak that Tesla have done in the background. So anyway, guys, I might finish up the video there. I think I've covered everything I wanted to. Yeah, I look forward to your comments on this video and having that discussion. So thanks again for watching. This has been another long video, but I think it's got a lot of valuable information, useful information. And what you're looking at here will be useful if you have a Model Y as well. So what we're looking at here, you're going to have some very similar figures. Your battery may have, even the newer Model 3s don't have 55 kilowatt hour anymore, they have the 60 kilowatt hour battery. So some of these figures are going to be a little bit different, but you're going to see the same differences between the full pack when new to the nominal remaining and the nominal full pack and those figures. You're going to see the differences of what we're looking at, and the cell imbalance and the voltage sag and things like that. So it's all going to be useful information. Anyway, guys, thanks for watching. I'll catch you next video.